In this question, you have a ripple tank, and you can imagine you drop a stone inside the water, and when it's viewed from the top, you have this circular wave produced, and all these circular lines here are called wave front. And you can imagine that this is the crest, and crest. Likewise from here, the wave adjacent to it. So a wave front is actually an imaginary lines that join all identical points that are in phase. For example, in this case, this line here joins all the crests. They are in phase. That means they have the same speed, they have the same direction at all time. And another important thing to know is that the distance between the wave front, that will be your wavelength. So in this case, you'll know that this 6 cm is actually the wavelength. It is given that in 2 seconds, 3 wave crests are produced on the surface, and the distance between the crests will be 6 cm. Now, because it's given on the diagram here, the 2 crests are here, and we already mentioned that since it's a successive crest, so that will be wavelength 6 cm. But the confusion is here. In 2 seconds, 3 wave crests are produced. Does it mean that there are 2 complete waves or 3 complete waves produced in that 2 seconds? Now, maybe as with this question as a reference, from now on when dealing with this question, you will treat it as, let's take a look here, treat it as this. This is the point where time equals to 0. This crest here, you don't count it, and then this will be the first crest as the wave is moving to the right, and this will be the second crest, and this will be the third crest. And if you look at the wave here, there are 3 complete waves, 1, 2, and 3. So 3 complete wave produced in 2 seconds. Okay, so if we understand this part here, we can go about solving the question. I'm going to show you 2 methods. Let's start with the first method. As you know, 3 complete wave, 1, 2, and 3. So the total distance from here to here will be 6 times 3, so that will be 18 cm, and it will take 2 seconds to travel that distance. So I can use my formula, speed equals to distance over time that you are familiar with, and the distance will be the wavelength 6 cm times 3 divided by 2, so that will be 18 over 2. That's why you get 9 cm per second. So you already have the speed. And then for the frequency, of course, you can use your wave equation, v equals to f lambda. Speed is 9, and the frequency is what you want to find. And earlier on, we already understand that 6 cm is the wavelength, so from here the frequency will be 1.5 hertz. So D will be the answer. The next method, if your approach is this, you can, if you understand that there are in 2 seconds 3 waves are produced, and frequency, the definition of frequency means how many complete waves produced in 1 second. Is always with respect to 1 second. So if you do your proportion method in 1 second, that will be 3 over 2, which is 1.5 wave produced in 1 second. In other words, 1.5 hertz. So you have the frequency answer, and then you can work for your speed. Speed equals to v equals to f lambda wave equation, and the frequency is 1.5, and the wavelength will be 6. And then from here, you know that the speed will be 9.0 cm per second. So either way, both are correct, so it depends on your approach.